Well, hello, my name is Sulev Reisberg, and I'm representing a recent paper about doing OMOP ETL in Estonia. First, a couple of words about Estonia. What is it? It's a small country in Eastern Europe, next to Finland and next to Sweden, and also we have a common border with Russia, but we are very different from Russia. And while the size of the land area is similar to Netherlands, actually our population is more than 10 times smaller, only about 1.4 million people, which means that we have more free space and forest, and we also communicate less, do everything online. And it has been said that Estonia is the world's most digitally advanced society. We pay the taxes online, we conduct the elections online, but we also check our health records online. And the key feature that enables that is the unique personal ID, which basically allows to link the information of the same individual from all datasets. We have a couple of universities here, but University of Tartu is the oldest and the largest one. And also our research group of informatics at our university has grown pretty large. And here you can see the group, and most of the people are behind the article I'm going to represent. The paper was published in JAMIA Open. Here's also the link to the paper, but you may think of it as yet another OMOP mapping work, but there are some differences that I want to highlight here. First of all, the health data in Estonia resides in different national health databases, and they are also governed by separate institutions. And the only legal way to link those datasets is either to treat the particular patient or to do the research. And the latter was exactly what we did. We applied for the 10% random sample from 3 national health databases, the claims, the prescriptions, and the EHR documents, the summary documents. And the sampled individuals were exactly the same from all databases. And we got the pseudonymized data, and then we turned everything to one single common data model. This is the general overview of the ETL process that we have implemented, actually the ETL pipeline. Well, it starts from extracting the necessary pieces of information from the source documents, then we clean the data. We use quite a lot the natural language processing on free text sections. Then we apply the concept mapping and so forth. And finally, we load all the data to the single common database. Well, the key thing is that the whole pipeline is fully automated, meaning that we can make adjustment to any step, either the fact extraction or add some mappings, and we can rerun the whole pipeline from the very beginning. And the resulting database has already been used in various studies. And in each study, we have made some improvements to the pipeline. And one of the lessons learned here is that participating in studies has helped us to improve the resulting datasets and also the pipeline bit by bit. So study by study, the pipeline becomes better and better, which is a very nice and useful thing. Now I turn to the reviewer 2. The reviewer 2 commented that starting with just 10% makes sense, but it would be great to have stats for other 90% too, which makes perfect sense. And we would like to do it as well. But this is the place where the legislation and the privacy comes into play, and especially if you're not the owner of the original datasets. No one is willing to give you the whole data to the researchers. So this 10% was some kind of a balance between the privacy concerns and the scientific objectives. However, the automation here is the key. And by now we have also applied for even larger random sample from the same datasets, and really believe that we can use the same pipeline without any major modifications to get the new OMOP datasets very quickly. Let's see how it goes. I'm not going to provide you any numbers from the paper, but this is actually my last slide. I personally think that the main value for the OHDSI community is the lessons learned table in the article. It's an extensive table of all kinds of lessons that we have learned during these more than 5 years of work, actually, with concrete examples, and we also provide the solutions for the challenges. I think it would be useful to have a look at this for everyone, starting to map their database to OMOP. But I think that there are also useful thoughts, for example, for those who build concept vocabularies, for instance. So this was a very brief overview of the paper, how we map the data to OMOP. But I can say that we have just yesterday submitted another manuscript which focuses more on the earlier step in the ETL, especially how to extract the information efficiently from the EHR documents, from these textual documents. And this, I hope that this publication will be published soon. Thanks.
Awesome. Thank you, Sulev. Maybe just quickly, one of the things you highlighted is that, and what I appreciate about this paper was you really did outline a system to ETL, whereas like we got a lot of papers out there that are like, we ETL'd, but it's not clear whether or not it's actually a end-to-end pipeline where you can just press go and run. Could you just comment a little bit more on now that you built this system, and you're commenting there briefly about like random samples mean that you could just start with a different input? Can you comment on what your experience has been about that and how much that's actually worked in practice?
Well, what we have done already is that we have actually we have conducted several studies, meaning that for instance, if we study COVID, then we apply for the data from the national sources, the same sources pretty much, of the COVID patients. And then we have the data, we have the similar documents, and we have just run the same pipeline, and it results in the OMOP common data pool that we can use all the other tools, right? As I said, in each study, some things come up, something we have to improve or change, but in the end, all the code base is still in the Git repository, and we basically improve the same thing over and over again. And it has worked pretty well, I would say.